Number 11. We've got an absolute value that we're going to graph. Looks like we got a transformation though. A transformation is occurred to the V shape, right? It's absolute value. This is the parent function. And this guy is moved to the left 2, it went up 1, and then it's going to switch. Okay, it's going to reflect. Okay, so this basically means just we're going to be pointing it down. So let's go to the location here, and then we're just going to point it down. All right. What we should think about though is we would go reflect him, and then we would move 2 up 1. Okay, so we're going to move 2 to the left, up 1, and then we're going to do that. Okay, now technically we did the reflection first. Okay, all right, I'm going to be careful right there because what I want the part of the function that is greater than or equal to 0. Now that's cool because that means I just want that part. Alright, this is the part that is above the x-axis. That's all that this means, okay? Above the x-axis. So we've already done something like that earlier, okay? So being above the x-axis, I'm looking at what is the domain from here to here because that's the piece that's greater than 0. And that is 1, 2, 3. That's negative 3. Okay, negative 3 to negative 1. But now we got to ask, do we include? Do I include negative 3? Do I include negative 1? So, if I can equal 0, then that means I will have this filled. This is okay to be 0 right there, and it is okay to be 0 here. Okay, so because of that bar right there, I'm actually going to put brackets on both of them because I am allowed to equal 0. If that bar would not be there, then these guys would be open parentheses. Okay. All right, solving the system here. All right, now this is actually this goes way back, right? Goes back to algebra 1. So I'm going to actually do this right here. I see that. Let's see. This guy's already negative, and that guy's positive. This is perfect way to solve the system. By elimination, right? So what I'm going to do is I'm going to multiply this part by 2, and by doing that, I'm going to double that y to 2, and then those will be able to cancel out. And then I'll just see what happens with the other numbers. So double everything here, I get 6x minus 2y equals 16. Alright, and then, ooh, this could be really messy here. X plus 2y equals 5. No, it's not. Okay, I thought we were going to get a crazy fraction. That's what happens in real life, but we're in a comfortable Algebra 2 class in high school, so we don't have to worry about that. Those guys cancel out now, the y's. Okay, I could have canceled out the x's if I wanted to, but this was kind of a perfect little match here, and all I had to do was double one line. Okay, and so with that, then you'll notice that these guys cancel, and now I got this little mini one-step equation, which tells me that x has to be 3 for this to be true. So I go back to any one of these that I want, and the x is going to get plugged in. I like to keep it as simple as possible, so I get a 3 right there. Let's use this guy. A 3 for the x equals 2 times something equals 5. And I got a little two-step equation. Put negative 3 on both sides, and I get 2y equals 2, so then y equals 1. Alright, so what does my solution look like? If I'm going to solve a system, that means that two lines are basically going to crisscross, if I were to look at this graphically. And so what it is, it's a point. So the x-coordinate is 3, and the y is 1. Now don't confuse this with a domain. Okay, the context says solve, and so we're not concerned about this being a domain here. Okay, if it said solution interval, then this would be a domain, a window of values. Okay, unfortunately, they can mean the same thing. That's why the context is actually very important. Okay, what is the equation in vertex form of a parabola with this vertex? But it has to pass through this point. Okay, so if we just take the vertex, all right, we can get 2/3 of the equation done. Alright? 2/3 of the equation is going to look like this. I'm going to leave actually a space here. And there's a reason for that. I know that the vertex is to the right 4 and up 2. So to the right 4 would look like this. And it's a parabola, so I got to have a square. And I'm going to go up 2. Okay? Now that's 2/3 of the, I was more than 2/3 of the equation done. Okay? But the thing is that even though this guy has a vertex here, we have to kind of swing the arms of the quadratic so it fits perfectly, fits perfectly and hits that point 2, 0. So we've got to modify it so that the arms are either spread out or they tighten up so that it'll pass through. Okay? So what I have to do in this case, if I'm going to modify this guy, I have to put an A here. Okay? It cannot be assumed that the A is 1 all the time. Okay? We've got to make this guy pass through a point. So what you do is this. So now you don't know what the A is, alright? Alright, but it has to pass through the point. So what you do is you plug in the point. Well, the X is actually 2, so we just substitute the X for 2. Okay, and then the Y has to be 0. Okay, so we are just plugging into the point. Now notice though, the way that we write our equation, notice how the X is on the right hand side and the Y is on the left. It's because we always kind of write our equations like this, but when we write points, we put the X first and the Y. So it's a little weird, but these guys are going to go into their coordinate, right? Okay, they're going to go into their position, their slot. Now, all we got to do is solve for A. Order of operations is important here. So what we've got to do is, we've got 0 equals, and I'm going to keep A pink here, times, this is going to be 2 minus 4. 2 minus 4 is negative 2 squared is actually 4, positive 4, plus 2. Okay? Now, what's going to happen then is I get A times 4 is just 4A. What I've got is a two-step equation. Alright, so if I just solve this, subtract 2 to both sides, negative 2 equals 4A, and then, A just went blue now. I'm going to divide by 4, so now I get, alright, and then this is going to be simplified to negative 1/2. Okay, so this means that when I graph this guy, I need to modify my equation so that the A is negative 1/2, so that it will, that should be a negative 4 squared plus 2. That's my answer. Okay. Now let's think about this for a second. Okay. Now I know this is a practice test, so I want us to think about this. Is negative 1/2 reasonable? So let's go to 4, 2. 4, 2. 4, 2, 1, 2, 3, 4, 1, 2, 2, 2, 2, 2. Okay, so that would be the vertex. Okay, now I need it to pass through 2, 0. So 2, 0 is actually right there. Do you guys see why this has to be negative? Okay, notice that this guy has to point downwards to pass through that point. Okay, so that's good. That's actually very, and it had to widen so that it could pass through 2, 0, and that is why it's negative, and that is why it's a fraction. Okay, if it would have been 4, 0, then this thing would have had to go upwards, and we would have found in our result that that would have been a positive. Okay. All right. So always check for the reasonableness of your answers. We'll do this. Last problem here for this video. Function is a transformation of the parent function. Okay, so we got a square, got a quadratic. The graph is a translation of right 5. Move to the right 5, and then it went down 3. So basically, which one of these is that? So looks like, oh man, I got doubles again. Look at B and C; they're the same thing. Okay, I wonder if that's the answer. All right, well, let's. What you do to get vertex to standard is you just have to multiply these guys out. Okay, so take the x minus 5 and just double him, because that's what that is saying. We're doubling x minus 5, and then don't forget that in the end we will subtract 3. But what you can do is just put a box around him. Don't forget about him, but just focus on multiplying these two first, because order operations requires us to do multiplication. Alright, so x squared, and then x times negative 5 is negative 5x. Then I multiply those two, negative 5x. Then I get negative 5 times negative 5, which is positive 25. And then there is the negative 3. Okay. Alright, so then x squared, bring those together. That's minus 10x. And then these two together are going to give me positive 22. Alright, so it looks like B and C were not the answer. It looks like it is A. Alright, so that's all you got to do to go from vertex to standard. To go from standard to vertex is a whole nother matter. That is actually for a curriculum class. We are not going to do it this year.